According to the National Electrical Code, specifically Section 300.3c, electrical non-metallic tubing, or ENT, shall not be installed in switchgear. There are several reasons for this prohibition. Firstly, ENT is not designed to withstand the high temperatures and mechanical stresses that can occur within switchgear. Switchgear is an enclosed space that houses high-voltage equipment. Running a low-voltage conduit, such as ENT, through the switchgear could create a hazard or interfere with the operation of the equipment. Secondly, it is a violation of the NEC to install any electrical wiring or conduit that is not specifically approved for the application. If faced with a situation where someone requests you to run a low-voltage conduit through switchgear, it's recommended to politely inform that person that it is not permissible due to the NEC violation. Suggest an alternative solution, such as installing a dedicated conduit for the low-voltage wiring outside the switchgear. If they insist on disregarding the NEC, document the conversation and request their instruction in writing. This will protect you from any potential liability. The NEC provides specific guidelines for electrical installations to ensure safety and prevent hazards. Adhering to these guidelines is crucial when working with electrical systems, especially in environments with high voltage equipment like switchgear. When selecting conduit for electrical installations, it's essential to choose a type that is approved for the specific application and environment. Factors to consider include the voltage level, temperature range, and potential mechanical stresses. Different types of conduit, such as rigid metal conduit, intermediate metal conduit, and electrical metallic tubing, have different characteristics and are suitable for various applications. Rigid metal conduit, or RMC, is a heavy-duty conduit that offers excellent protection against physical damage and corrosion. It is typically used in exposed locations or areas where mechanical protection is required. Intermediate metal conduit, or IMC, is a lighter weight alternative to RMC, offering similar protection at a lower cost. Electrical metallic tubing, or INT, is a thin-walled conduit that is commonly used in concealed locations. It is easy to bend and cut, making it a popular choice for residential and commercial wiring. Electrical non-metallic tubing, or ENT, is a flexible conduit that is often used in walls and ceilings. It is lightweight and easy to install, but not suitable for all applications. When installing conduit, it's important to follow the manufacturer's instructions and all applicable codes and standards. Proper installation techniques, such as using appropriate fittings and supports, are essential for ensuring the safety and reliability of the electrical system. Also, be sure to properly bond the conduit to ensure a continuous ground path. Grounding is the process of connecting the metal parts of an electrical system to the earth, providing a path for fault current to flow back to the source. This helps to protect people from electric shock and prevent damage to equipment. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors and the methods for connecting them. A grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. The grounding electrode system must be connected to the building's main electrical panel and to any other separately derived systems, such as generators or transformers. In addition to grounding, bonding is also important for electrical safety. Bonding is the process of connecting together all of the metal parts of an electrical system, creating a low impedance path for fault current to flow. This helps to equalize the voltage potential between different parts of the system, reducing the risk of electric shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect together metal enclosures, raceways, and equipment. The size of the bonding jumpers must be appropriate for the size of the circuit conductors. The NEC also specifies the requirements for overcurrent protection, which is the use of fuses and circuit breakers to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a certain level, preventing damage to wiring and equipment. Fuses are single-use devices that melt and break the circuit when an overcurrent occurs. Circuit breakers are reusable devices that trip and open the circuit when an overcurrent occurs. Circuit breakers can be reset after they trip, while fuses must be replaced. The NEC specifies the requirements for the size and type of overcurrent protection devices based on the ampacity of the circuit conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The NEC provides tables that list the ampacities of different types of conductors. When selecting overcurrent protection devices, it's important to choose devices that are properly rated for the circuit. The overcurrent protection device should have an interrupting rating that is high enough to safely interrupt the maximum available fault current at the point of installation. The interrupting rating is the maximum amount of current that a device can safely interrupt without being damaged. The NEC also specifies the requirements for wiring methods, which are the ways in which electrical conductors are installed and supported. Wiring methods include conduit, cable, and wireways. The choice of wiring method depends on the application, the environment, and the applicable codes and standards. Cable is a group of two or more insulated conductors enclosed in a sheath. Cable is commonly used in residential and commercial wiring. There are many different types of cable, each with its own specific characteristics and applications. Some common types of cable include non-metallic sheath cable or NM cable, armored cable or AC cable, and underground feeder cable or UF cable. Non-metallic sheath cable or NM cable is a type of cable that is commonly used in residential wiring. It consists of two or more insulated conductors enclosed in a non-metallic sheath. NM cable is easy to install and relatively inexpensive. Armored cable, or AC cable, is a type of cable that has a metal armor that provides protection against physical damage. AC cable is often used in commercial and industrial applications. Underground feeder cable, or UF cable, is a type of cable that is designed for direct burial in the ground. UF cable is used for underground wiring to outbuildings, such as garages and sheds. Wireways are enclosed channels that are used to route and protect electrical conductors. Wireways are often used in industrial and commercial applications. There are many different types of wireways, each with its own specific characteristics and applications. Some common types of wireways include surface metal raceways, underfloor raceways, and cable trays. Surface metal raceways are metal channels that are mounted on the surface of walls or ceilings. Surface metal raceways are used to route and protect electrical conductors in exposed locations. Underfloor raceways are channels that are installed under the floor. Underfloor raceways are used to route and protect electrical conductors in commercial buildings. Cable trays are open support systems that are used to support and route electrical cables. Cable trays are often used in industrial applications. In addition to the requirements for wiring methods, the NEC also specifies the requirements for electrical equipment. Electrical equipment includes devices such as switches, receptacles, lighting fixtures, and appliances. The NEC specifies the requirements for the installation and use of electrical equipment to ensure safety and prevent hazards. Switches are devices that are used to control the flow of electricity in a circuit. There are many different types of switches, each with its own specific characteristics and applications. Some common types of switches include single-pole switches, double-pole switches, and three-way switches. A single-pole switch controls a circuit from a single location. A double-pole switch controls a circuit from a single location, but it switches two conductors instead of one. A three-way switch controls a circuit from two locations. Receptacles are devices that provide a connection point for electrical appliances. There are many different types of receptacles, each with its own specific characteristics and applications. Some common types of receptacles include standard receptacles, ground fault circuit interrupter receptacles, and arc fault circuit interrupter receptacles. Standard receptacles are the most common type of receptacle. Ground fault circuit interrupter receptacles, or GFCIs, are receptacles that are designed to protect people from electric shock. GFCIs detect ground faults and interrupt the flow of electricity, preventing electric shock. Arc fault circuit interrupter receptacles, or RFCIs, are receptacles that are designed to protect against electrical fires. SIs detect arc faults and interrupt the flow of electricity, preventing fires. Lighting fixtures are devices that provide illumination. There are many different types of lighting fixtures, each with its own specific characteristics and applications. Some common types of lighting fixtures include incandescent lighting fixtures, fluorescent lighting fixtures, and light-emitting diode lighting fixtures. Incandescent lighting fixtures are the oldest type of lighting fixture. Fluorescent lighting fixtures are more energy efficient than incandescent lighting fixtures. Light-emitting diode lighting fixtures, or LED lighting fixtures, are the most energy efficient type of lighting fixture. Appliances are devices that use electricity to perform a function. There are many different types of appliances, each with its own specific characteristics and applications. Some common types of appliances include refrigerators, stoves, washing machines, and dryers. Refrigerators are appliances that are used to keep food cold. Stoves are appliances that are used to cook food. Washing machines are appliances that are used to wash clothes. Dryers are appliances that are used to dry clothes. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. Adhering to the NEC is essential for ensuring the safety and reliability of electrical systems. When working with electrical systems, it's important to be aware of the potential hazards and to take appropriate precautions to protect yourself and others from injury. Always de-energize circuits before working on them. Use insulated tools. Wear appropriate personal protective equipment such as safety glasses and gloves. If you are not qualified to perform electrical work, hire a licensed electrician.